Although this discussion has focused on test scores and class size, the idea expressed in equation 4.2 is much more general. So it is useful to introduce more general notation. Suppose you have a sample of n districts. Let capital Y sub I be the average test score in the ith district, and let big X sub I be the average class size in the ith district, so that equation 4.1 becomes big E of big Y sub I given big X equals beta sub naught plus beta sub 1 big X sub I. Let U sub I denote the error made by predicting a big Y sub I using its conditional mean. Then equation 4.2 can be written more generally as big Y sub I equals beta sub naught plus beta sub 1 big X sub I plus U sub I, equation 4.3. For each district, that is I equals 1 through n, where beta sub naught is the intercept of this line and beta sub 1 is the slope. The general notation, beta sub 1, is used for the slope in equation 4.3 instead of beta sub class size, because this equation is written in terms of a general variable big X. Equation 4.3 is the linear regression model with a single regressor, in which big Y is the dependent variable and big X is the independent variable, or the regressor. The first part of equation 4.3, beta sub naught plus beta sub 1 big X sub I, is the population regression line or the population regression function. This is the relationship that holds between big Y and big X on average over the population. Thus, given the value of big X according to this population regression line, you would predict the value of the dependent variable big Y to be its conditional mean given big X. That conditional mean is given by equation 4.1, which in the more general notation of equation 4.3 is big E of big Y given big X equals beta sub naught plus beta sub 1 big X. The intercept beta sub naught and the slope beta sub 1 are the coefficients of the population regression line, also known as the parameters of the population regression line. The slope beta sub 1 is the difference in big Y associated with a unit difference in big X. The intercept is the value of the population regression line when big X equals 0. It is the point at which the population regression line intersects the big Y axis. In some econometric applications, the intercept has a meaningful economic interpretation. In other applications, the intercept has no real-world meaning. For example, when big X is the class size, strictly speaking, the intercept is the expected value of test scores when there are no students in the class. When the real-world meaning of the intercept is nonsensical, it is best to think of it simply as the coefficient that determines the level of the regression line.